assigned a letter 2 to our number 2 to our letter B, and so on and so forth. So you can assign the number 3 to our letter D, and so on and so forth. Now you can try to do this to the last one, okay, to the last one, and hence you assign number 26 to our final alphabet, which is Z. Okay, so by doing this, you can now convert all this English alphabet within this order into numbers. Okay, so for example, in here for the first letter N, now what is the places? What is the position of this letter N? So you can count it, because in here we know that, okay, so I is 9, and then J is 10, and then K is 11, L is 12, M is 13, and then N is 14. Okay, so we now can convert it into the number 14. So we can do this. Once we convert all of them, you can see it is much easier for you to know what are the orders of all these letters. So for example, from C, so it would actually come from it represents 3, and then for D it represents 4. I'm sorry, this is 4, and for E, which is 5, and so on. So in here, by converting them into numbers, you can easily see that there are actually 2 patterns in here. One is for the red number, 14, 15, 16, 17, and 18, and so on. Now the other is for the green number, which is 3, 4, 5, and hence we will guess that this symbol shall represent 6. Okay, this symbol should represent 6. Okay, so but what is the letters that represent 6? It is our letter F. Okay, so in this question, the answer shall be F. Okay, so this is our first question. This is our first question. Is there any question? Now, if there's no question, then we will go on for our second question. Now, question.
We can move on to the second question.
Have 7 sweaters. Robert have 3 fewer sweaters than William. How many sweaters do they have altogether? So, just by this statement, Robert have 3 fewer sweaters than William. We can calculate how many Robert have, right? So Robert will have, because it has 3 fewer than William, but William have how many of them? They have 7, right? So it will be 7 minus 3, because 3 fewer than William, which represent 4. Okay, so Robert actually have 4 sweaters. Okay, so how much sweater do they have all together? Now, notice that in this question, I do not ask you how many do Robert have. How many does Robert have? No, I ask you how many sweaters does they have altogether. So you need to include both William and Robert. So William have 7, Robert have 4, and hence they have 11 in total. So our answer shall be 11. Okay, our answer shall be 11. Okay. So for question number 3. So question number 3, Sarah is 9 years old now, and Hillary was 16 years old 3 years before. What's the difference between their age? Now, again, since we have a statement like this, Hillary was 16 years old 3 years before. So what is her age now? What is her age now? So we can easily calculate it because it is 16 years, 3 years before, 16 years old, 3 years before. And because after 3 years, it will have three more for her ages. So it will be 16 plus 3. So we know that it is 19 years old now. It is 19 years old now. Okay. Excuse me. Could you now? I'm sorry because if you are speaking while I'm discussing the questions, it will be very hard for other students to listen. So please, if you have any questions, please ask them on the chat room. Okay, please ask them on the chat room instead of raising your voices during the class. Okay. So now we have two information. Sarah is 9 years old and Hillary is 19 years old. What is the difference? What is the difference? So now it is simple because we can immediately compute that the age of Hillary, which is 19, minus the age of Sarah, which is 9, and hence the difference is exactly 10 years. Okay? So our answer for question number 3 is 10 years. Okay? So this is question number 3. Okay, so let's go to question number 4. Let's go to question number 4. In years 2021, how many months are there with 31 days? Now, this is actually not a mathematical question, but instead it is more a question about common knowledge. So within a year, how many months are there of 31 days? So we know that for our January, it is of 31 days. Now for our February is not 31 days. It is usually 28, but if it is a leap year, then it will be 29. So February is not 31 days. And the next one will be March. Okay, the next one will be March. And then for April is usually 30 days. It's always 30 days. No, it's not usually. It's always 30 days for April. And then the next one will be our May. Our May is 31 days. And then for our June is 30 days. And for our July is 31 days. So we now have 4 months, which is of 31 days. Now, and then we will go on for our August. August is also 31 days. And then for our September is 30 days instead of 31 days. And then we will go to our October. Okay, our August and then October. And finally, now November is 30 days. It is not 31 days. So for our final month within a year, we have 31 days will be December. So there are 1, 2, 3, 4, 5, 6, 7, and hence there are exactly 7 months. Now it will be very useful for you to know this kind of common knowledge, because later on, if we need to count how is the day of the week changes when time passes. For example, a typical question is, now today is 27th of March, right? So what is the day of the week for our 27th of December? So at that time, you need to know how many days for each month. So this question number 4, is asking you these common knowledge, okay? So there are 7 months, which is of 31 days, okay? Okay, so let's go to question number 5. According to pattern shown below, how many this clause within the circles are there in the 10th group? Now, again, every time you see this keyword, according to pattern, every time you see this keyword, if it's advisable for you to convert these patterns into numbers. It is always like this. It is always like this. You can convert this pattern into numbers. Now, what does that mean? It means something like this. Now, in our first group, do you see any cross within our circle? No. So we will assign a 0 for this group. So for our second group, we see one of them. So assign 1 in here. So our third group will see a 3 in here, because we see 3 symbols. And for our fourth group, you will see a 5 here. Okay. So disregarding the first question, this first symbol. So now, sometimes you may not find the patterns of this pattern, to find the rules of this pattern all along. So you may try to draw an extra diagram. Let's say now we'll draw the question for the diagram for our fifth group. So for our fifth group, it will be something like this. For our fifth group, it will be something like this. Okay, so and then you will see that there are, according to your patterns, it will have a circle in here. It will have another circle in here. It will have another one in here, and so on. Now I assume that there are a cross within the circles. No, so this is the final one. So by this, you will see that there are 7 numbers within 7 symbol within our fifth group. Okay, this is our fifth group.
What's the 7?
So what is the pattern? What is the pattern? Now, excluding the first number, all other number 1, 3, 5, and 7, they are all odd number. They are all odd number. So you know that, oh, so in here, this pattern actually follow. If you convert this pattern into numbers, you can see that you are just simply counting the odd number.
But teacher, why is not number 0?
Now, so that's why we disregard the first group, because the first group is special. The first group is special. Okay. Other than the first group, all other numbers are all odd numbers, are all consecutive odd number, not just any odd number, but consecutive. So you can clearly see that in here, for example, for our sixth group, they should have 9 symbols. They should have 9 symbols. And by this, you can see that since our rules is the consecutive, they are all consecutive or odd number. They are all odd number in order. So you can simply count them. You can simply count the odd number. Now, one thing to remember, one thing to be cautious here, because for us now in here, because our first group, unlike any other, our first group is of the number 0. It's of the number 0 instead of 1. So we start by counting 1 on our second group. So instead of the 10th odd number in our 9th group, so in here it should be our 9th odd number for our group, our 10th group. So it is not the 10th odd number for the 10th group, but instead it will be 9th odd number for our 10th group. But what is that number? That number is 17. That number is 17. So our answer for this question is 17. Okay. So again, it is advisable for you to convert this pattern into numbers and try to find out try to find out the relationship between the numbers. Once you convert into numbers, it is very clear. The relationship is very clearly seen. Okay. So this is for our problem 5. This is for our problem 5. Okay. So let's go to the final question of this section of the logical thinking. So if 5 days later will be Monday, which day of the week is today? Now, every time you see this question in here, because the day which we concerned is not very far away from the Monday that we have been given. Okay, so that's why we can simply just count them by hand, right? Now, I know that some of you may find that, oh, in mathematics, you try to count things. Okay, so it seems not very math, right? Math is actually, isn't it? Math is the way of adding or subtracting numbers. No, I should say, because counting is one of the most important, if not the most important method of mathematics. So now in here, I will draw out the, I should draw the day of the week for our calendar. So you know that the day of the week now it is of Monday, right? So this is now, okay? Oh, so this is 5 days later. Okay, so now by this you can try to count them by hand. Okay, you can try to count them by hand. So this is of Monday, so it means that 4 days later it will be Sunday. Okay, 4 days later it will be Sunday. And then 3 days later it will be Saturday.
Oh, teacher.
Yes. Yes. So your question, 2 days later it will be Friday. Yeah. And hence 1 day later it will be Thursday. And hence we know that what is the day now? What's the day now? The day now, it would be Wednesday, right? Wednesday. So by simply counting the number, we already know the answer. So the answer for this question, it will be Wednesday, right? So please do not disregard the power of simple counting. Now, sometimes if a question, especially for the numbers, when the number is small, it is much easier for you to count them by hand. Okay. Now, so this is the final question for logical thinking. Is there any question for this part? If no, then we will proceed to our next part, arithmetic. Okay, so let's go to our next part, arithmetic. Now, so this is very mathy, in so to speak. It is the section in which it looks the most mathematically. Okay, so in here this is all about counting all about adding and subtracting the number. Okay, so find the value of this number, 43 minus 14 and plus 6. Now in here, I would like to just rearrange the number. So instead of 33 minus 14 first, because minus 14, it will require you to just lower, just carry down the number, because 3 is insufficient to minus the 4 here. So instead, we will try to add 6 first and then proceed to minus 14, okay? So if that's the case, so we now would like to add our first number together. We would like to add our first number here, okay? So 43 plus our 6. What is the answer? The answer will be equals to 49. Okay. So hence it will be 49 minus 14. Now this is much simpler because now we can subtract it by digits. Okay. So because 9 can be subtracted by 4, and then our
35, teacher.
Our 4 can be subtracted by 1. So our answer will be equals, because of 4 minus 1, it will be 30. It will be 3. And our 9 minus 4, it will be 5. So the answer will be 35. Okay, so 35 is our answer for this question. Now, again, you can, if you wish, try to do it from left to right, and there is no problem for doing this. But if you try to do it following the same order as our questions, you will face something like this. So it will 33 minus 14 plus 6. And for 43 to minus 14, it will be, the answer will be 29. 29 plus 6, and again, you will get 35.
Teacher, I can send the message on the chat.
You can't send the message on the chat room. Excuse me.
Yes.
I'm not so sure why you can't do this.
I think it's 13.
No, this is not 13. This is 35.
35.
Yes. All right. Remember that for this part, 43 minus 14, you need to carry downward. All right, because our 3 is insufficient to subtract the 4 here. So you need to carry over from 4 to our unit digit. Okay, so the answer is
my teacher said want to do this. We need to, example is we need to is 17 plus 13 is 30, because 30 is easy to plus.
No, you don't add. You do not now. Listen, you do not do a question because it is easy. You do the question because it is precise. It is correct. Okay, please do not twist this question to suit your need, because you will find that it's easier to calculate. No, you calculate as told by these questions. Okay, please do not add or subtract a number simply because they are easy to do. No, you don't do that. Okay, so let's go to question number 8. Find the value of 17 plus 14 plus 15 plus 11 plus 16 plus 9. Again, this question requires you to rearrange number. Now in here, we would like to talk about a technique which we called a sum to 10. Now, what is the meaning of sum to 10? It is like this, because the numbers in here, if you rearrange it in the following sense, so now we can rearrange it in here, 16 plus 11 plus 9. Now, all these numbers, they are exactly the same as our original number. They're exactly the same as our original number. I just rearranged them. But why we rearrange them now? Please look at these pairs, right? Look at these pairs. For our 17 plus our 18,
I said pay that. It's 80.
This would be equal to, what is the answer of 17 plus 13?
Teacher, I said pay like that. Teacher.
Excuse me, what's your question?
17 plus 13 equal 30.
Yes, it is equal to 30. Now,
plus 16 equal 30.
Excuse me, I'm sorry, it is also equals to 13, okay? Now again, you can see that if we try to sum them up, you will find that the answer is the same. Now, the answer will have a 0 as its unit digit. Now, this is good. This is good because once you try to sum them up like this, they will have a find digit as 0. Now, this is what we meant by sum to 10. This is what we meant by sum to 10. Okay, so whenever we want to find the two digits in which they will sum the unit digit 7 and the unit digit 3, they will sum up to 10. Every time we want to calculate this arithmetic fast, we want this number to be summed to precisely equal to 10. Okay, because once we sum it like this, after which it will be very easy for us to try to sum up our 30, and 20. So what are the sum of this number?
Excuse
me, could you, I'm sorry. I am sorry. Could you please do not raise your voice during the lesson? Could you please not raising your voice during the lesson? Because I cannot, the other student cannot listen to what I've said. Please be considerate.
Mute everyone. Look.
Okay, so this is our answer is equals to 80. Okay, the answer is equals to 80. Okay.
Em làm rồi. Phương My ơi, đang cất bớt đồ đạc đi cháu tiếp tục được.
So let's go to question number 9. Let's go to question number 9. If A represents the same first digit number, what's the value if the equation is correct? What's the answer of it if this question is correct? Okay, so in here you can see that since during our sum, the 10th digit doesn't change. It doesn't change, which means that there are
Teacher.
Excuse me, what's your question?
Wow.
Phương My ơi, ăn giò nào.
24 equal 28.
Của con không nhìn được.
8 is 4.
Because there are no carryover, which means that in here, our A plus A is exactly equals 8. Now, there are actually two possibilities. It can be either equal to 8 or it is equal to 18. But because there are no carryover, that's why we know that it must be equal to 8. Okay. It must be equal to 8. Excuse me, could you please not speaking during my lesson?
Teacher.
If you continue speaking, then I may consider kicking you out of this classroom. Please do not speak. If you have any questions, please try to ask them on the chat room. I will modify the chat room and answer your question.
Teacher.
Please do not ask any question again, because it is seriously disturbing the flow of this class.
Mute everyone.
Okay, let's just continue. Because A plus A is equals to 8. And now, of course, it means that this is actually equals to 2A. So by this we
The
know that
answer is 4.
A must be equals to 4. Okay, so we know that our answer is equals to 4. Okay. So let's go to our question number 10. Let's go to our question number 10. What is the number that should be filled in the blanks if the equation below is correct? Excuse me, could you ask the questions on the chat room? Please do not speak again. It is seriously disturbing the flow of this class. Now, let's go back to question number 10. What is the number that should be filled in the blanks if the equation below is correct? So we have a number, which is our 17 minus this number. Now, this number, we do not know what this number is, right? We do not know what this number is. But again, we can rearrange it. We know that by this, we can rewrite it as the following. Our 17 is equals to our number plus 12. Or in other words, this number that we want is what we want is exactly equals to 17 minus 12. Or in other words, it is exactly equal to 5. Okay, so our answer for this question is equals to 5. Okay, so this is our question number 10. This is our question number 10. Okay, let's go to question number 11. Let's go to question number 11. If C is a one-digit number, what's the value of C if the equation is correct? Now, just like our last question, we can rearrange this number into rearrange this equation in the following. So we know that our 18 is equals to our C plus our C. Now, just like this. Now, in here, we know that our 17 minus our blue number is equal to 12, and hence our 17 is equal to our blue number plus 12. And like this, because our 18 minus C is equal to C, so our 18 is equal to C plus C. But this is also equal to C, which means that we can divide both sides by 2, and hence we'll get our answer, which is C is equals to 9. C is equal to 9.
Teacher, answer is 9. 9 plus 9 equals 18.
Okay, so this hence our answer is equal to 9. Excuse me, could you please not speaking during the classroom? Okay, let's go to question number 12. And let's go to question number 12. Find the value of this number. Now, there are so many numbers. How many numbers are there in question number 12? There are actually 20 numbers. There are actually 20 numbers here. So it is very, very difficult to add this number all together. But unfortunately for us, these numbers are separated into batches.
Teacher, answer is 55. 55.
So you can see in here that all we can separate this 20 number into 5 different groups. Okay, we can separate this number into 5 groups. For each group, they are all 1 plus 2 plus 3 plus 5. So you can try to add this group, all this number within the same group first before you calculate the total sum. Now for 1 plus 2 plus 3 plus 5, the answer is equal to 11. So this question is equivalent to asking you what is the value of the sum of 5, 11 together, okay? This is equivalent to asking what's the sum of 5, 11. But we know that for adding 5, 11, the answer will be equal to 55. 55, because you can add the 10th digit together. 1 plus 1 plus 1 plus 1 plus 1 is equal to 5. And then you can add the unit digit together. 1 plus 1 plus 1 plus 1 plus 1 is again equal to 5. So you will get an answer which is equals to 55. Okay. So let's go to our next question. Now, our next question, we now come to the next topic, which is number 3. The number 3 is all about integers and the okay. Now, although I would like to caution you that it is unlike the final topic, which is our combinatorics. This counting is always about prime, is about all the special numbers, okay? So now let's go to our question number 13. Question number 13. Ella have 19 peers and James have 7. How many peers does Ella have to give James to make them having the same number of peers? Okay, so let us look into this final part. Now, this type of question is called the exchange.
Teacher, n square is 8 plus 4 minus 2 plus 9.
Now, what do you mean by our exchange program? Exchange program is the sum. Exchange program it means that for within this question, all the objects, now in this case, it is the peers are changing hands from one people to the other, but the total sum of all peers within this group is unchanged. The sum is always the same. Okay, the sum is always the same. Now, this is the most important characteristic of the exchange program. So in here, we know that the total sum for our peers, how many of them? It will be 19 plus 7, and hence the total sum, it is equals to 19 plus 7, it is equals to 26. So we know that there are 26 peers in total. And if that's the case, now here comes the question. How many peers did Ella and James have to make them having same number of peers? It would be, means that they will have 13 peers. Ella and James will have 30 pairs for them to have the same number of pairs. Okay, they will just be half of the total.
Teacher, I don't hear the sound.
Okay, this will be half of the total. Okay, So once you know that their final distribution, okay, once they know that you know all the final distribution, could you please stop drawing on the screen? Unless I told you so, please do not stop, do not draw on the screen. Okay, so now let's go back to our questions. Since Ella now start with 19 peers and they end up with 30. So how many of them they will need to give to James? So our answer will be equals to 19 minus our 13. So our answer will be equals to 6. So the 6 peers are our Ella needs to give the 6 peers to James. So this is our answer. This is our answer in here. Okay. So this is our question number 13. This is our question number 13. Oh, is there any questions? If no, then now we proceed to our question number 14. Question number 14. Okay, so for our question number 14, filling the lines with plus and minus to make the equation below correct. So we know that 8, 4, 2, and 9, we need to add them to equals to 19. Now, if we just simply add these numbers all together, if you just simply add this number all together, you will get the answer, which is equals to our 8 plus 4 plus 2.
Do we have?
This would be equals to our 23.
Teacher, answer is 8 plus 4 minus 2 equal 9.
Now, because in here, we can see that the numbers in here is different from the numbers here. They are different by 4. They are different by 4. Okay. So this difference, you can have this difference only if you convert a number or convert the sign of one of this from plus to negative, and it will only happen if that number will have a difference which is twice of the corresponding number, and hence we know that our answer could be equal to 8 plus 4 minus 2 plus 9 is equal to 19. Now notice that in here, notice in here, if we convert our plus 2 to our minus 2, the difference will be, the difference is equals to 2 times 2 is equals to 4, exactly like the one that we require, right? The difference in here is exactly the difference.
Teacher, how many questions more?
Now we have 30 questions. We have 30 questions. We are almost done half of them, okay? So please be patient. Please be patient. We have done almost half of them, okay? We will. Okay.
Teacher, why 9 plus? Yeah. 10.
So our
Teacher, who
answer
draw
here,
here?
please do not draw on the screen. Please be considerate and do not draw on the screen.
Excuse me, may I go to the bathroom?
Okay, so our answer is 8 plus 4 minus 2 and then plus 9. Okay. So let's go to our question number 15. Well, let's go to our question number 15. Determine the result of 2 plus 3 plus 5 plus 6 plus 8 plus 9 plus 10, 11 and 12 is odd or even. Now, in here, actually, you can try to sum this number all together to find the exact result instead of talking about whether it is odd or even, the polarity. But in here, because we just want to know it is odd or even. Now, remember, for odd and even, there are simple rules for them. There are simple rules of them. It is like the odd number, when it is summed to another odd number, it would be equals to a odd plus a odd number, it is equals to even. A even number plus a even number is also equals to even. But a odd number plus a even number is actually equals to odd. So by this, we can simply just count them one by one. Okay, so in here, first of all, this is, so for 2 and 3, it is 2 is a even number, 3 is a odd number, and hence the sum of this, it is a odd. Okay, this is a odd number. Now, and then because it will be added to another odd number, so odd plus odd, now it becomes even. Okay, and then we can continue to do this. A even number plus another even number, it will be even. Okay, and then if we continue to add by another even number, so 2 plus 3 plus 5 plus 6 plus 8, it is still even. Okay, now once we start adding up the odd number for our 9, once we want to add our odd number 9, then this would be odd, because it is even plus a odd number, and hence the whole number will be odd. And then if we add our 11, a odd number, add another odd number, it will be a even number now. And finally, because it's an even number, while it added to another even number, and hence our answer for this question is equals to even number. Okay. Now this is one way of doing this. This is one way of doing this. You just keep on counting from left to right the sum, whether they are. You just instead of calculating the exact value, you simply count whether it is equals to odd or even. Okay, whether it is equals to odd or even. Now another way to finish this question is for you to count how many odd numbers are here. How many odd numbers are here? Now you can see that our 3, 5, 9, and 11, they are odd number. So they sum up into an even number. And we also know that no matter how many even number you sum it all up, the result will be always equals even. So because they have a odd number of odd, and hence they have an even number of odd, and hence the result would be equals to even. Now this is another way of doing this question, of finishing this question, because all this even number of odd, according to these rules, according to rules in here, they will sum up into even. Okay, so we have finished half of this paper. We have finished half of this paper. Congratulations. Now let's finish the other half of this paper. Okay, now let's go to question number 16. Let's go to question number 16. By observing the number, which odd number is the smallest? Now again, let's just count which of them is actually a odd number first, before we talk about which one of them is smallest. So if you can see that 16 is not an odd number, 48 is not an odd number, 24 is not an odd number, 6 is not an odd number. So the only three odd numbers in here is 35, 13, and 21. Now, but remember that if a number need to be the smallest, their most significant digit, which is this one, or this number, the most significant digit, which is our 3, 1, and 2 in here, they need to be smallest. So which one of them is smallest? It is our 13 is smallest. So our answer is equals to 13. Okay, so this is our question number 16. Okay, so let's go to our question number 17. How many two-digit even number that the unit digit is 2 are in here? Okay, how many two-digit number in which its unit digit is 2? So now again, every time we see this kind of question, we can now, because there are not much even number in which they have unit digit is 2, so we can count this by hand, right? We have 12, we have 22, 32, 42, 52, 62, 72, 82, and finally 92. So that's it. These are all of them. So how many numbers are there in here? There are 9 numbers, right? Again, I would like to stress that counting is the basis of many mathematical theories. And please do not put counting lightly in this one. Sometimes it is much easier for you to just list out all the number, right? Because how many two-digit even numbers that the unit digit is 2 are here? These are all the numbers: 12, 22, 32, 42, 52, and up to 92. Now, the next number, which will be bigger than that would be equals to 102. Now, but 102 is bigger than this, and hence it is not one of them, right? Okay. So let's go to question 18. Let's go to question 18. Now, this is an arithmetic series. Now, what do you mean by arithmetic series? Now, an arithmetic series is the following. The arithmetic series is the series in which all neighboring numbers, they have the same difference.
Teacher, I can't.
Arithmetic series is the all neighboring numbers have the same difference. Okay. Now, what does that mean? Now look at the numbers look at the neighboring numbers in here. 118 and 112. They have a difference of 6, right? They have a difference of 6. Now let's look at another pairs of neighboring number 112 and 106. They have the difference of 6 again, right?
Hi, teacher.
And for yes.
Please, teacher.
Yes. I'm listening.
My return to the post before I take a picture.
I'm sorry. Could you repeat it one more time?
My return to the post before I take a picture.
Excuse me. What does that mean? I'm sorry. I do not understand.
Come back. 15.
Or maybe, okay, let's just continue. Now, again, in here, for our 194, the difference is again 6. Now, this, because all that difference are the same, we say that they have the same difference. We say that they have the same difference. In this cases, this we will so-called the common difference. The common difference in here, it is equal to 6. Okay, the common difference in here is equal to 6. Now, if they have the same difference, then we call it a arithmetic series. So in the following sense, you can see that all the number after the first number is we keep on subtracting 6 from our series. We keep on subtracting 6 from our series. Okay, so our first number is our 118. This is our first number. Okay, maybe I just move this a little bit higher. Disregarding this. Now let's proceed to find our answer. So our first number is equals to our first number is equals to 118, and for our second number, it is equals to our 112. But what is 112? 112 is equal to 118 minus 6, right? Because they're different. They have a difference of 6, right? For our first number is equal to 106. But what does that mean? It means that this is equals to our 112 minus 6, right? But it's also equal to 118 minus 26, okay? So if we proceed to list them out, you will soon find our pattern here. So our 100 is equals to 106 minus 6. But what is this? It is equal to 118 minus 36. Now, in general, now you can see in here that for all this number 1 to 4, they will subtract 16, 26, and 36 respectively, right? So they have in general, they will follow this pattern. It is if we subtract our nth number, it will be 118 minus our n minus 1 times 6. Okay, so this is the general term. This is the for nth term. It will be 118 minus our n minus 1 times 6. So in particular, if it is our 18th term, so if it is 18, we simply need to subtract 17, 6, okay? So our 18th term, it would be equal to our 118 minus our 17 times 6. Now, but what is the result of 17 times 6? 17 times 6, it would be equals to 1, 6 times 2, is 102, right? So our answer is equals to 16. So our answer is equals to 16. Okay, this is our answer. Okay, is there any question? Now, every time we see that we want to ask what is this number? All you need to do is just subtract this by 1 and then place it so that you will subtract our first term by 1 minus this number. Okay, our first term, of course, you don't need to subtract any of it. It will be equal to first term, but for our second term, you need to subtract 1 of the common difference. For our third term, you need to subtract 2. And for the fourth term, you need to subtract 3. And hence, by this logic, our 18th term, you need to subtract it by 17 of the common difference, which is 6. Okay, so this is our question 18. This is our question 18. Is there any question? If no, then we will go on to talk about the next topic, which is geometry, the topic about graph and diagram. Okay, referring to the figures, we know how many 9 segments is and are there. Now notice that in
me.
here what we yes. Yes, what's your question? Now in here we talk about 9 segment, but what is a 9 segment? Again, we want to know the meaning of it. A 9 segment is actually a line with both starting and its finishing point. Okay. Now, usually if I just give you a line, they will not have any starting and finishing point. Now, although because if we draw a line, it must start from somewhere and end with somewhere. But usually when we are saying line, we mean a line which is of infinite length. It will extend it all the way up to the places outside of the screen.
11. Answer is 11.
Oh, really? So let's check. Okay, let's check.
Yes.
Now, because of this, we want to calculate what they mean by. Now, notice that if the two lines, although they may be of the same direction, but if they do have the different starting or finishing point, they are considered different line segments. Now, let's look into it. Now, for example, in here, now let's focus on this line. Let's focus on this line. This line, this red line. How many line segments within this line?
3.
Yes, 3. Because if we have now let's draw it out like this. So this line segment is exactly the same as the one on our left. Or the one on our right is exactly the same as our one on our left. So because if we want to count the line segment can be like this, starting from the first point to our second point. It can be starting from our first to our third, and starting from our second to our first. So there are 3 for this line segment. For this line, 3 line segments for this line. Okay. So by the same logic, we can count each line and to see how many line segments are there for each of this one. Okay. So let us compute it one by one. So for blue line, again, if there are 3 points in here, so there are again 3 line segments. For our green line, there are again 3 points in here. They will have 3 line segments. Now for our orange line, because there are only just one starting point and 1 finishing point there, and hence for our orange line, they will have only 1 line segment. And for our pink line, it will also have only 1 line segment. So how many line segments are there in total? This would be equals to 3 plus 3 plus 3 plus 1 plus 1. And hence our answer is 11. All right, the answer is equals to 11. Now again, please notice that the line segment means a line with both starting points and the finishing point. If they have different starting points or they have different finishing points, they are considered different line segments, even if they are on the same direction. Even they are on the same line. If they have different starting and finishing point, they are considered different line segments. Okay. So let's go to our question 20. Question 20. How many signs are there in the polygons below? Well, we can count it by hand, right? This is our first line, first side. This is our second side. This is our third. This is our fourth. This is our fifth. This is our sixth. This is our seventh. This is our eighth. So in total, there will be 1, 2, 3, 4, 5, 6, 7, 8. And hence our answer is equals to 8. Okay. So we just count the we just count it one by one. Again, please do not think that mathematics we do not count in mathematics. In fact, we count a lot in mathematics. So sometimes when the diagram is simple, it is much easier for us to simply count it by hand. Okay. So this is the meaning of, this is the answer for our question 20. In here, we just count each side one by one. Okay, so let's go to our question 21. Let's go to our question 21. According to the pattern shown below, excuse me. So according to the pattern shown below, what's the figure in the space provided? Now, in here, we want to find the repeating pattern. So the so-called repeating pattern, which we have another word which is suitable for it. It is called the cycle. Okay, the cycle. Now, what does that mean? Now, if you look into this, you can separate all this symbols into different groups.
Answer is triangle.
A triangle.
Answer is triangle.
Okay, so let's see.
It's triangle. Answer is triangle.
Okay.
Answer the triangle.
Now,
Triangle.
yes, I've heard you saying. Okay, so let's see. Let's look at it together. Let's look at it together. So, according to the pattern shown below, you can see that we are keep repeating the same pattern. It was always a rectangle first, and then a stars, and then a triangle. Always a rectangle first, and then a stars, and then a triangle. So in here, if we look into this pattern, this particularly instant of the pattern, again, it starts with a rectangle and then a star, and finally, which means that it must be end with a triangle. So all of you are correct, right? This must be a triangle. Very good. Okay. So again, whenever we see this kind of pattern, we would like to see if there are some repeating pattern, repeating.
It's triangle, teacher.
Yes, this is triangle. Okay, so this is triangle. Okay. Okay, so let's look at question 22. Let's look at question 22. This is known that the figure 1 is formed by 4 cubes. How many cubes are there in figure 2? Now again, we can see this a repeating pattern. Now, if we say that this is a which is formed by 4 cubes. So we can see that there are one set of it in here. There are another set of it in here. There are another set of it on the side of it, and there are another set of it on the side of our blue, right? So in total, they will be like 4 plus 4, right? This will be 4 in our leftmost, and then we have another 4 for our blue, and then we have another 4 for our green, now there's another 4 for our green, then there's another 4 for our blue, and finally there are another 4 for our red. So in total, there will be 4 plus 4 plus 4 plus 4, and hence our answer is equal to 16.
We use 4 misleading. 4 equals 6.
Okay, this will be 4 plus 4 plus 4 plus 4 is equal to 16. Okay.
Teacher, go
Yes.
to the next question. It is 16.
No, that's 16. Because there will be 4 for our orange.
Yes,
set.
I know it. I know it's 16. You go to question 23.
Excuse me, what does that mean? Anyway, let's continue our discussion. For our next question is our 23. For question number 23, how many sides
Oh
are there
my
in
God,
polygon
side
below? Now
again.
again, we need to count it one by one. We need to count it one by one, but this time we need to be very, very careful because the sides looks like they look exactly the same. So you need to be very, very careful. So these are one sizes, one, and this is the second one. This is our third. This is our fourth. Now I use different colors for this because they are very, 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 very similar. So let's
Teacher,
look at,
who drawn it?
And
notice that these two, they are not the same sizes. They have this line are of different direction. Again, this is the fourth, there's a fifth of them, and then there was six, and then they are the seventh, and then
And
they
we
are
said
the
9.
eighth,
and 13.
and then let's go back to our 9, and
I
finally it will go to our 10. Okay, so in total there will be 10 sizes.
Okay, teacher, I will say 10 side.
It is 10 size.
Okay, this will be 10 sizes.
Okay.
Okay, so let's go to the next question. Our next question is question 24. Question 24. How many squares are there? Now in this time, we want to count the square one by one. But
1, 2,
unlike the last time, we want to count it by different sizes. Now, because there's so many squares in here, we would like to count by sizes. Okay. Now in here we have a sizes which is
I will
of
say
the smallest, like this.
13 square.
How many
14
sizes like
square.
this? It would be one by one. This is so-called one by one. How many squares are there which is one by one? So there will be one in here. There will be 1, 2, right? 3, 4, 5, 6, 7,
Good.
our 7, our 8, and our 9. So there are 9 squares of one by one. There are 9 squares of it. Again, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now, but this is not just a square of one by one. There are also a square of 2 by 2, like this. Like this. This is a square of 2 by 2. So how many squares are there for 2 by 2 square for this? So again, let us count it together. This is
2,
1.
teacher.
This would be 2.
Why?
3.
And then we will be 3. And then it will be 4. Okay, so there are 4 different squares of it. So 1, 2, 3, and 4. So in total, how many of them are there in here? In total, how many squares are there? So the 9, which is 1 by 1, and then 4, which is 2 by 2. So the total number of them is
30,
equal to
teacher.
13.
14.
30.
Okay, so our answer is equal to 13.
Number 30.
Okay, so this is our question number 24. This is our question number 24.
Oh no.
Okay, so let's look at our final section, which is our topics of combinatorics. Now, what do you mean by combinatorics? Combinatorics is a method of counting. Now, again, we have used many. combinatorics is the method of count, is the math of counting. So we will continue to count all this number. Okay, so let's go to our question number 25. Our Jackson will have 10 $1 coin. So what's the value of this 10 number coin? 10 coins, because there will each of them is of $1, so it of tens, and hence it will be of $10, right? It will be of $10. Okay, so but what is the how many dollars are there? How many dollars should there be if we need to convert them into $2? So we can convert them into actually $5 $2. So our answer is equals to 5. So our answer is equal to 5. Okay. So we just find out the total value of this of the money that Jason have, and then we convert it into $2 because we have $10 in total. So we know that it can be converted into $5 $2 because $5 $2 also is $10 in total. Okay. So let's look at question number 26. Let's look at question number 26. We want to separate 8 as sum of two one-digit number. So again, how many ways are there? So we can immediately count it by hand, right? We can count it by hand. We can write that it is 1 plus 6. Now again, 1 plus 6 is 8. Now is there any other way? Let's say 1 plus 7 is equal to 8. 2 plus 6 is also equal to 8. And then we have 3 plus 5, again equals to 8. And finally, it will be 4 plus 4 is also equal to 8. Now, but the next one that we would like, now, notice that one thing is that when we are counting, we are following the order. You can see that for our first number,
0 plus 0. 0 plus 8.
Now,
0 plus 8 equals 8.
Oh, yes, because now one of you raises a very good question. There's still one of them, which is 0 plus 8, right? 0 plus 8, okay? So in total, there will be 5 of them. Now notice that our first digit are always on our descending or on our ascending order. They're always on our ascending order in here. So this is a particular way of counting things. Remember, when we are counting things, we do not want to count it twice. We do not want to miscount them. That's why we gave them an order, order of counting things. Okay, so in here we will start from the smallest one-digit number, which is 0. So it will be 0 plus 8, and then will be 1 plus 7, 2 plus 6, 3 plus 5, 4 plus 4. Now the next one, because following the pattern here, the next one should be 5 plus 3. But 5 plus 3 is equal to 8 is not acceptable. It is not acceptable. Why? Because we consider them both as the same method. Because in here, consider 4 plus 7 and 7 plus 4 as the same method. So in here, we do not count this. We do not count this. So we only count the number, the different distribution on our top. So how many numbers are there in here? So
Teacher, why we don't count this? 3 plus 5.
There will be 5 methods, 5 ways of doing this.
But teacher, but why we don't set with 6 be 3 and 5 and 5 3 the same?
Yes, because we treat them the same. Yes, that's why we do not count them. We only count the first 5 of them. Okay, so this is our question 26. This is our question 26. Now let's go to our question 27. Now let's go to our question 27. According to the values of the following expression, how many 2-digit numbers is and are there? So this in here now, unfortunately, because we need to find out whether they are the 2-digit number, hence we need to find the values of all this number. Now starting with the first number, 6 plus 3, our answer will be equals to 9. Okay. So for our second number, 18 minus 7, the answer will be 11.
18.
The answer will be 11. So for our next number, which is 12 minus 5, our answer will be equals to 7. For our next number, which is our 19 minus 16, the answer will be equals to 3. And for our next number, 2 plus 2, our answer will be equals to 4. Now, there's only one way for you to see whether or not it is a 2-digit number, is to find the exact value of them. So there's no easy way of doing this question. You need to calculate each number separately. Okay, so for our 14 minus 9 is equal to 5. And finally, for our 5 plus 8, 8 is equals to 13. Okay, so now in here, how many of them are a 2-digit number? So in here, we have our 11 is a 2-digit number, and our 13 is also a 2-digit number. So in total, there are 2 of them. So in total, there are 2 of them. All right. There are 2 numbers in which the expression is a 2. The value of the expression is the 2-digit number. Okay, let's go to our question 28. Let's go to question 28. Which number below is smallest? Again, now recall the last time we talked about the smallest. What do you mean by smallest? What do you mean by smallest? Well, now for a number to smallest, it would be that we compare the most significant digit, compare the digit. We compare the digit starting from our most significant, which is our rightmost digit. Oh no, not our rightmost digit. This is should be leftmost digit. Okay. We compare the digits starting from the leftmost digit. So now let's compare it one by one. So our leftmost digit is 2, right? The leftmost digit is 2, and for our leftmost digit is 2. They are all 2. Okay. So they are the same. So we still don't know which one of them is larger. So
the number of months.
So again, we will compare the next one, which is 0. Okay. We'll compare the number is 0. Again, they are all the same. They are all the same. So we still don't know which one of them is the smallest. And then we compare our next digit is 2, 1, 2, and 2. Now in here, we know which one is smallest because all of this is 2, but only this one is 1. So it has the smallest, most significant digit. It has the smallest digit. it will have a smallest digit, other smallest digit, and then others. Okay, so our 2101913115 is the number which is smallest. Again, every time we want to know which one is the smallest, we compare the digits starting from the leftmost up until to our rightmost. Our rightmost digit is the least significant digit, so always we count it from our left to our right. And whenever there are one digit in which they're different, we will choose the one which have the least on this digit, on that digit. Okay, so our answer is 20191315. Okay, so let's go to our next question. Okay, what is the minimum distance that you need to travel if the distance between adjacent one is equals to 1 meter? So again, we want to pack them all up. We want to pack all this to pack it. We want to pack it all. Pack this. Pack all within one stroke. Now, what do you mean by within one stroke? It means that we pack them all in one. We do not go back to the same position to pick all this up. Yes, right? We will pick it within one stroke. So we can start from in here. We can start here. We pick this two. We start from this apple. We pick one of them and then two.
Teacher, have only 5 minutes.
4.
Yes. Teacher, faster. Have only 5 minutes.
Yes, only 5 minutes. So we have only 2 questions left. Okay, so we will be finish it on time. Don't worry. So we will keep on picking it until to our final apple. Okay. Now remember, we need to count how many lines are here. How many lines are here? So this would be 1, 2, 3, 4, 5, 6, 7,
8, 9, 10,
8, 9,
10, 11, 12, 13,
10,
15,
11,
16,
12,
16,
15, 14, and finally 15. So we know that the minimum distance, it will be equals to 15 meters. Okay. So this is our question 29. Okay, finally, let's go to our final question. Which is our question 30. Choose 4 digits without repetition from 0, 1, 4, 7, 8 to form a 2-digit number and minus them. What is the maximum value of the digit? What's the maximum values of the difference? Now, let us count how many 2-digit number can we write from this 5 number. Okay, how many 2-digit number? Now, because we want them to have the maximum value of difference. So let us write it in here. So we have a number which is of 2 digits, and then we want to subtract it by another number of 2 digits, like this. Now, because we want the difference to be a maximum difference, we want it to have maximum difference. So how can we make sure that it has maximum difference? It will mean that first of all, this number, the number on our leftmost, this
Teacher,
one
have 2
must
minutes.
be
Faster. Have only 2
must
minutes.
be the largest. Yes, I know. Okay.
I'm so hungry.
Okay, and the number on our right must be the smallest one, right? So what is the largest number and the smallest number by using this 5 digits? So again, we know that if it is the largest number, the first digit must be the largest, so it must be 8.
27.
And followed by another second largest number, which will be 7, right? For our smallest number, the first digit must be smallest, but notice that in here, we cannot use, this cannot be 0. It cannot be 0. Okay, so the only number that we can choose other than 0 and such that this is the smallest.
Teacher, have only 1 minute. Faster.
This should be 1. Okay,
1
and then
and
this
4.
should be
4.
equal to
0.
0, right? So what is the
77.
difference?
77.
Yes, exactly, 77. So our maximum difference will be equals to 77, and this is our answer. Okay, so this is the end of this paper. Is there any question for this paper? Now, if you have any question, feel free to ask it after this lesson. And if you have no question, then thank you very much for your attendance. Then I hope you have a wonderful day and week.
Bye-bye, teacher.
And we will see you next time. Okay, bye.
Bye-bye, teacher.
So if you have any questions, feel free to ask.
Teacher.